I'd like to now introduce Atorod Azizinamini, our presenter for the ABC Safety and Mobility presentation. Atorod is the Vasant H. Surti Professor of Civil Engineering at Florida International University and Director of the ABC-UTC. Atorod?
All right. Thank you, Marilu. I hope everyone see my screen. And again, very warm welcome to the symposium. And thanks for the opportunity. This presentation, as Romeo mentioned, we had the schedule for Romeo Garcia, our liaison with the FHWA, to provide the presentation, but because of the time constraint and so on, I got the privilege of giving this presentation. So some of the material that you will see was obtained from the FHWA, and toward the end, I have some additional material that was developed at ABC-UTC at FIU that I would like to share with you. So the presentation outline, again, some introduction and some list of some of the FHW alternatives, how to address the safety in the construction zones, and then I will very briefly discuss the overview of the FIU work and make some conclusions and maybe a path forward. Okay. So everyone intuitively understands and accepts that the ABC, one of the biggest aspects of the ABC is the safety and the mobility, and the construction activities appears. I put the appears because until we quantify these items, that's the main reason why I use the word appears. But intuitively, I mean, it is well understood that anytime you have a construction zones, it's a magnet for the accident, for the injuries, and the fatalities. And regardless of many safety measures that FHW has taken, workers and publics are still exposed to construction zone related hazards in the roadways. People still text and drive regardless of how well the states, FHWA and AASHTO takes the measures so that that doesn't happen. Now, ABC results in shortening of the construction period, and one could logically say that the shortening of the construction period using ABC should result in reducing the safety and hazard because you have less number of the days that you have the construction workers on the job site. You have a lower number of the days that there are construction zones, and that reduces the roadside hazards both for the publics and the workers. Now, ways to quantify the relation between the ABC and roadway safety is not really well understood. And when I say the relationship, by that I mean to quantify, to being able to quantify that. Now, limited work has been conducted at FIU very recently, trying to quantify. Now, this work was conducted by our transportation faculty and one of our PhD students that just graduated, Dr. Sajjad Mokhtarian, and we can provide you his contact information for additional information. Okay. So first, allow me to show you some of the alternatives that FHWA and the consortium of the roadside safety have proposed in order to reduce the hazards associated with the roadside safety. Now, these are well familiar. Most of you already know, and I'm just going to go through the list, nothing more than that. So one option, of course, is the full road closures, that you can close the roads completely, and that will allow basically the construction to go on and at much faster pace. Another option, again, I won't go too much in detail, is a diversion. Basically, as you see in this slide, diversion is a temporary rerouting of the road users onto the temporary highway or alignment placed around the work zone. So that's another option you have. Or you have the median crossover which is used to close entirely one side at a time of a divided multi-lane highways, moving all traffic to the other side, basically. Ramp closures. Anytime you close the ramp, you reduce the number of vehicles that are on the roads, and therefore you reduce the roadside safety hazard. Rolling roadblocks is where you have the law enforcement vehicles with light flashing entering the roadway upstream of the work zone and move at a fairly slow pace to create a basically blockage across the travel lane. And it's really mainly suitable for temporary traffic control situations. And also working during the nighttime, that's another option. It is believed that by performing work zone activity at night or weekend to avoid the high traffic volumes. Nevertheless, one of the conclusions that our transportation people made was that even though the traffic is low, but the nature of the accident and injuries and so on changes during the daytime and the nighttime. And one of those 7 alternatives that is proposed by the consortium of the roadside safety groups and the FHWA is the ABC. And so over the next slide, what I will do is to provide you the overview of the work that has been completed at FIU. Again, this is a very preliminary work, but I think it's a first step and a right step in the right directions, which can finally lead to being able to quantify the relationship between the safety and the ABC. And when I say quantify, it means that to assign a dollar value, and the reason for that is that for decision makers. Why do we need that? When the decision makers basically wants to decide whether the ABC or convention, they would like to have, okay, what dollar value can I assign to the safety aspect of the ABC? So over the next slide, I'm going to show you very brief, very overview, and I don't claim to understand everything that went into developing these conclusions. These are more on the transportation, traffic issues. But it's good that a structural engineer is showing that, because I try to comprehend the conclusion and pick those aspects that is interest to the structural engineers, to the bridge engineers. So hopefully I will be able to communicate that with you. So as I said, FIU study has proposed a methodology. Okay, this is a general methodology. Has proposed a general methodology that could be adopted to different regions. The catch is a data. We need to have a data. Okay, FIU study has limitations. Okay, it's not universal and needs additional work. Now, in order to develop this methodology, our group used the Miami-Dade County as a test bed and proposed the methodology. Okay, where one can assign, actually, you can assign a dollar value to the safety, and I will provide you with one example to show you what I mean by that. So this dollar value that's associated with the safety aspect of the ABC, okay, is really includes the kind of the damage, the cost of the damage to properties, the cost of the injuries, the cost of the fatalities. So by that I mean to collect all the hazards, translate into basically the dollar value, and then say, okay, if you use ABC, this is how much you will save, because it's how much you're going to prevent the injuries, accident, and the fatalities. And the way our group have done, and the data, the availability of the data is the biggest factor. So when our group looked at the data, there is a crash severity information in the, let's say, in a corridor, in a bridge side, and so on. So, but you need to take that data. Our transportation group took that data and translated that into the injury severity, because when there is an accident, there is a report that how many people got injured, how many fatalities did you have, and so on. So they took the crash severity, they turned it into an injury severity in all those 5 categories that you see here, and each one of them there is a dollar value that you can assign each one of them, and that's how they came up with the dollar value assigned to the safety aspect. So let's take a look at the example problem. Now this is lots of assumptions have gone into applying the methodology that our transportation group developed into this example. The example that they used is the Graves Avenue over I-4 ABC project. This was back in the 2006 in June 3rd, I believe. And in fact, I was at my University of Nebraska Lincoln, and I made a trip actually. I made a trip to come to Orlando and to see this. So this was a 2-span bridge. They constructed the 2-span completely off-site, as you see on the left-hand side of your screen, and then they transported using the SPMT to the final site. And the final site, I think, was maybe a mile or so. And you can see here is a photo of the entire 1 span is left by the SPMT and is being moved into the final location. And I was on the side, and it was this was back in 2006, where any ABC project would attract thousands of people, and people coming from all over the world actually to take a look at it. So now what's important, now this is the material that is reported by the Florida DOT, Florida Department of Transportation, okay? We took it from their website. According to the FDOT, the lane closure on the I-4, because of using ABC, was reduced from 32 nights that would be associated with the conventional type to 4 nights. So, so we are not, in the number that I'm going to give you, doesn't include the user cost. So the user cost saving, according to FDOT, was $2.23 million. Okay. Now our group took the data that they had. They said, okay, based on, long story short, for this project, ABC would take 4 days, and the FDOT said that okay, it cost $28 million. Conventional would have required the 32 days of lane closure and would have cost $27 million. So the difference was about $500,000. Okay. Now our group came up with a number that you see down here that says $11,018 per day. This is the cost of all the injuries, accident, fatalities, and everything else that can happen if you do a lane closure per day. So that $11,018 is the cost of lane closure per day, and that is the cost of the injuries and all that. Again, there's a lot more going on behind that numbers. Now, if you save 28 days, that means that the safety aspect of the using the ABC in this project would translate into $308,518. So that's how this basically the work has concluded. Okay. Now I'll make just a very brief conclusion. So a general methodology is proposed that its accuracy is related to large extent to availability of the data. The crash data is critical to this methodology, but the methodology is there. You just have to populate with the data. Okay. And for the first time, we can claim that we can assign a dollar value to every day reduction in the lane closure, which is really associated with the safety aspect of the ABC. And like I said, additional work needs to be done to take the FIU work to the next level. So with that, I will stop, and I'll do my best to answer any question that's possible.
Okay. Thank you, Atorod. It's about time for our next presentation, but we could ask one question. So what is the next step to take this work to the next level?
I believe, Mehlut, the next step is some additional work needs to be done, but it's a very interesting concept that our group have developed. And I think there needs to be some additional work. And maybe one aspect would be that maybe some states, if they are interested, they could develop a pool fund or something to take this work, or FHWA, if it's interested, to take this work to the next level and come up with the general methodology and steps that, okay, to give to the state, okay, go through these steps, develop these data, and then you can come up with a number that you can say, this is how much dollar per lane per day I can save if I use the ABC versus the conventional reflecting the safety aspect of the ABC.
Okay, thank you.